Have you ever wondered how many people it would take to establish a sustainable human colony on Mars? Yes, Mars, our neighboring red planet, a world that has captivated our imagination and scientific curiosity for centuries. Well, a team of US researchers did more than just wonder. They embarked on an intriguing study to unravel this cosmic conundrum, utilizing the power of sophisticated modeling and simulation. Their mission? To determine the minimum population size necessary to establish a successful, thriving colony on Mars. A colony that wouldn't just survive but prosper. The stakes are high, get the numbers wrong and the Martian colony could end up a dismal failure, a ghost town of deserted habitats and abandoned dreams. It could turn into a real-life Lord of the Flies scenario, or worse. The researchers were not just playing a game of numbers, but a high-stakes gamble with the future of human interplanetary colonization. This wasn't an easy task. The researchers had to account for a myriad of factors, including the challenges of long-duration space travel, the harsh Martian environment, the need for self-sufficiency, and the psychological pressures of living in a remote, isolated colony. Their approach was both meticulous and innovative. They used a technique known as agent-based modeling, a method often used in health and economic studies. This computer-based simulation allows researchers to study the interactions between independent decision-making agents within a system, including people, objects, and the passage of time. The researchers considered not just the quantity but also the quality of the potential colonists. They factored in different personality types, skills, and other variables, such as resource availability, interpersonal relationships, and task pairings. They even looked at human experiences in high-stress, isolated environments like Antarctica, submarines, and the International Space Station to gain better insights. So after all the data crunching and scenario simulations, what was their conclusion? The magic number they determined is 22. Yes, according to this study, you'd need at least 22 pioneers to kickstart a thriving Mars colony. A small step for a team, a giant leap for mankind. This estimate is significantly lower than a previous one of 110 people. The shift in numbers is not just a minimalist change, it's a shift that is potent with many layers of meaning and consequences. It's a number that carries with it countless assumptions and implications. A figure that speaks volumes about our collective future as a species. A number that alters the course of our current thinking about interstellar travel and the establishment of human colonies on other planets. It's a statistic that can change the trajectory of space exploration, that can redefine the parameters of what we believe to be possible and achievable. It's a figure that has the potential to reshape the way we view the universe and our place in it. It's a number that invites us to rethink our priorities, to reassess our strategies, and to redefine our visions of the future. It is a figure that causes us to reassess our capabilities and to challenge our assumptions about what we can achieve as a civilization. The decrease in the number of people required to establish a self-sustaining colony on Mars has profound implications for the feasibility of such a venture. While the prospect of living on Mars may seem like a far-fetched dream, the fact that this dream could be achieved with fewer people makes it more realistic and attainable. The lower number means there would be fewer mouths to feed, fewer bodies to transport, correspondingly smaller logistical puzzle to solve. This reduction in numbers would mean that the resources required to sustain life on Mars would be significantly less. It would mean fewer supplies to transport, less food to be grown, and fewer living spaces to be built. It would mean that the cost of the journey could potentially be reduced, making the dream of Mars colonization a more affordable reality. This shrinkage in the number of required settlers also alludes to a decrease in the amount of resources that would need to be expended. Fewer people mean less demand for food, water, and oxygen, and a lower need for energy production, waste management, and other essential life support systems. These reductions would significantly decrease the overall cost of the mission, making it more financially feasible and potentially more sustainable in the long term. The potential savings don't stop there. With fewer people to launch into space, there would be less for expensive and resource-intensive transport vessels. Fewer people would mean fewer rockets, less fuel, and less infrastructure to support the mission. This decrease in mission size could potentially lead to significant cost savings, making the journey to Mars even more viable. The implications for scientific research and technological development are equally profound. With fewer people to support, there would be more resources available for scientific exploration and research. This could lead to greater understanding of Mars and its potential for human habitation, which could have far-reaching implications for our understanding of the universe and our place in it. Moreover, the smaller estimate could help to streamline the mission, making it more efficient in terms of both time and resources. This increased efficiency could lead to faster timelines for mission completion and a quicker return on investment. It could mean that the dream of colonizing Mars could become a reality sooner than we think. The smaller estimate is not only a big deal in terms of the practical implications for a potential Mars mission, but it's also a big deal in the grand scheme of Mars colonization. This reduction in required population size could significantly alter our perceptions of what's possible in terms of space travel and colonization. It could redefine our understanding of what it means to be a spacefaring civilization, and could potentially open up new possibilities for human expansion in the cosmos. However, it's critical not to lose sight of the broader implications of this figure. The ability to establish a self-sustaining colony on Mars is about far more than just numbers. It's about the future of our species, about our capacity for exploration and discovery, about our ability to adapt and survive in new environments. It's about our potential for growth and development as a civilization. So, while the smaller estimate is significant, it's important to remember that it's about much more than just the numbers. The Mars Colony Project is a testament to the power of human ingenuity, determination, and resilience. It embodies our collective aspiration to explore the unknown, to push the boundaries of our understanding, and for a better future. It's a project that encapsulates the essence of our species, our curiosity, our courage, our tenacity. It represents our shared dream of a future in which we are no longer confined to one planet but can expand our horizons beyond the Earth and into the cosmos. In this grand endeavor, every reduction in the required population size brings us one step closer to realizing this dream. It's a step towards evolution of our species, towards a future where we are not just visitors in space but permanent residents. Every reduction in numbers is a step towards a future where Mars is not just a distant planet but a second home for humanity. However, it's not just about the numbers. The researchers found that the simulated Mars colony needs to have the right mix of personality types. Now this is where things get interesting. The success of a Martian colony doesn't just hinge on the number of pioneers, but also on the blend of their personalities. Yes, you heard it right, personalities. Imagine this, you're on Mars, millions of miles away from the nearest humans outside your group. It's not just about surviving, it's about living together, working together, and making a home out of a foreign land. That's why the mix of personalities is so crucial. The team identified 4 key personality types that need to be present for the colony to thrive. First up, we have the agreeables. These are the peacekeepers, the ones with low competitiveness, low aggression, and low fixation on routine. They're the glue that holds the group together, keeping conflicts to a minimum. Next, we have the socials. These individuals are moderately competitive and require social interaction. They thrive in a community setting and are key to maintaining a healthy social environment. They may not be fixated on routine, but they sure know how to keep the morale high. Then there are the reactives. This group is also moderately competitive and excels in social interaction. However, they also have a strong fixation on routine. They keep things running smoothly and ensure that tasks are completed on time. And finally, we have the neurotics. These individuals are highly competitive, socially aggressive, and have a high fixation on routine. They also tend to get bored easily. While they may be challenging to handle, their drive and ambition can push the colony to achieve more. Each of these personality types brings something unique to the table. The agreeables foster harmony, the socials build community, the reactives maintain order, and the neurotics drive progress. It's a delicate balance, but when achieved, it can create a resilient and thriving colony. So it's not just about getting people to Mars, it's about getting the right people to Mars. Without the right blend of personalities, the whole endeavor could go belly up. And we certainly don't want that, do we? Beyond the technical and engineering challenges, future colonists will face psychological and human behavior hurdles. This statement sets the stage for the myriad of obstacles that lie ahead for those daring enough to venture forth and plant the seeds of a human colony on Mars. Imagine, if you will, the immense pressure of being one of the few, the 22, tasked with not just surviving, but thriving on a planet millions of miles from Earth. The weight of such a responsibility is not to be taken lightly, and the psychological toll it could take on an individual is not to be underestimated. Our reliance on Earth won't simply cease with our arrival on Mars. In fact, the dependency will increase. The colonizers will be dependent on Earth for resupply and replenishment of necessities. Mars is not a bountiful planet. It lacks the resources we take for granted here on Earth. Mining a few basic minerals and water will not be enough to sustain a colony. Technologies capable of splitting Martian water into oxygen for breathing and hydrogen for fuel will be essential. Then, there's the isolation. Living in a small community, cut off from the rest of humanity, will likely lead to a whole host of psychological challenges. The environment will be harsh and unforgiving, the atmosphere thin and lacking in oxygen, the landscape barren and devoid of life as we know it. How we interact, how we cope, how we adapt, will all play a crucial role in the success or failure of the mission. The right mix of personalities is key, but so too is our ability to work together, to overcome adversity, to innovate and problem solve. We must prepare for the unexpected, plan for the worst, and hope for the best. The road to Mars is fraught with challenges, but each one is an opportunity for growth, for learning, for progress. To better understand these challenges, the researchers used a technique called agent-based modeling. And that, friends, is where we'll pick up in our next scene. Stay tuned. Agent-based modeling is a computer simulation technique used to study the interactions of autonomous decision-making agents in a system. Now let's dive into understanding this technique a bit more. Agent-based modeling, or ABM, is usually employed in health or economic research. But in the context of our Mars colony, what does it mean? At its core, ABM is a computational method enabling a researcher to create, analyze, and experiment with models composed of agents that interact within a system. These agents could be anything: individuals, organizations, or even a whole country. The beauty of ABM lies in its ability to capture the dynamic and often unpredictable nature of complex systems. In the Martian settlement study, the researchers used this method to simulate a colony of pioneers. They factored in various elements that could impact the success of the colony. For instance, they considered resource availability. The colonists would need to have enough food, water, and other essential supplies to survive. They also took into account interpersonal relationships. The pioneers would be living in isolation for a prolonged period, and their ability to work together harmoniously could significantly impact their survival. The researchers also considered task pairings in their simulation. Each colonist would have a specific role to play in the settlement, and how well they performed their tasks could determine the colony's success. For example, some might be responsible for growing food, while others might be tasked with maintaining the settlement's infrastructure. But the researchers didn't stop there. They included 4 different personality types in their model: agreeables, socials, reactives, and neurotics. Each personality had its unique characteristics and skills, either in management or engineering. This diversity was crucial to simulate a real-life scenario, where different personalities and skill sets coexist. The team also studied human experiences in high-stress isolated environments like Antarctica, submarines, and the International Space Station. These experiences provided invaluable insights into how humans behave and interact when confined to a small space for extended periods. So, what does all this mean for our future on Mars? Well, it paints a complex picture. It's not just about getting a crew there, but also ensuring that crew can survive and thrive. A minimum of 22 pioneers carefully selected for a balance of personality types could be the magic number to establish a sustainable colony. However, the challenges are many. Beyond the technical and engineering hurdles, the colonists will face psychological and behavioral obstacles. The isolation and the high-stress environment are factors that shouldn't be underestimated. And then there's the issue of resupply, with Earth being the only current source for replenishing necessities. The researchers' agent-based modeling approach gives us a unique perspective into the interactions of these future Martian colonists. As we inch closer to making Mars colonization a reality, these findings bring us one step closer to understanding what it will truly take to sustain life on the Red Planet.